An object from another star system is hurtling through our own, and it's not like anything we've ever seen. It's moving at a speed that defies easy explanation, its origins are a total mystery, and it's behaving in ways that challenge our very understanding of the cosmos. Now, for the first time, two of humanity's most powerful eyes, the Hubble and James Webb telescopes, are locked on to this impossible visitor. And what they're finding? Well, it just shouldn't exist. On July 1st, 2025, a network of automated telescopes designed to scan the sky for dangerous asteroids flagged something weird. This system, called ATLAS, the Asteroid Terrestrial Impact Last Alert System, is our planet's frontline defense against cosmic fender benders. But this was no ordinary space rock. As observatories around the world swung their gaze, a startling picture emerged. The object's path was just wrong. It wasn't orbiting our sun. It was moving way too fast on a trajectory that could only mean one thing. It came from the vast, dark ocean between the stars. This was only the third interstellar object ever detected passing through our solar system, following the bizarre Oumuamua in 2017 and the more conventional comet 2I Borisov in 2019. The International Astronomical Union officially designated it 3I Atlas, marking it as our third interstellar guest. But this visitor immediately stood out. It's the fastest comet ever recorded, and it appeared incredibly active. As our best instruments focused in, the mystery only got deeper. Humanity was about to get its closest look yet at a true piece of another star system. Not a spaceship, but a pristine relic from a world born long before our own. To figure out what 3I Atlas is, humanity has called in its best astronomical detectives, the Hubble Space Telescope and the James Webb Telescope. Think of them as the ultimate investigative partners, each with a unique skill set perfect for this cosmic chase. Hubble is the seasoned pro, our eye in the sky for over 30 years. It sees the universe in visible and ultraviolet light, which gives it an unmatched ability to snap incredibly sharp, detailed images. For an object like 3I Atlas, Hubble's job is to be the reconnaissance expert, to see its shape, pin down its size, and watch how it reacts to the sun's glare. It gets the visual evidence, the cosmic mugshot that tells us what we're up against. Then you have the James Webb Telescope, the next-generation powerhouse. Webb is a master of the invisible, built to see the universe in infrared light. This lets it do two things Hubble can't. First, it can peer through clouds of cosmic dust. Second, and this is the crucial part for 3I Atlas, it can perform incredibly detailed chemical analysis. By breaking down the infrared light coming off the object, Webb can identify the specific molecules and ices vaporizing from its surface. It's basically a cosmic CSI unit, dusting for fingerprints to reveal what this thing is actually made of. Together, they're an unbeatable team. Hubble shows us what it looks like, Webb tells us what it's made of. For an object that seems to defy our theories, this 1-2 punch is our best shot at understanding where it came from and what its existence means.
With the target in their sights, the investigation began. Hubble went first. On July 21, 2025, it captured the sharpest image ever taken of 3I ATLS. The picture was stunning. It revealed the object wasn't just a dead rock, it was clearly an active comet. A beautiful, teardrop-shaped cocoon of dust and gas, called a coma, surrounded a bright, hidden core. But Hubble's vision is so sharp that it allowed astronomers to do something remarkable: put a firm limit on the size of that nucleus. While early guesses were all over the place, Hubble's data narrowed the core down to somewhere between 320 meters and 5.6 kilometers in diameter, no bigger than a small mountain. This was a critical piece of the puzzle. Hubble also spotted the first hint of a tail streaming away, pushed back by the gentle pressure of sunlight. It was acting like a comet, but the big question remained: what kind of comet? This is where the James Webb Space Telescope comes in. Its observations, which began in August 2025, are designed to answer that very question. While the full dataset is still being carefully analyzed, the mission is crystal clear: hunt for the chemical fingerprints of its building blocks. Webb's powerful instruments are tuned to find materials like water, carbon monoxide, and carbon dioxide as they turn from solid ice into gas to form that glowing coma. Measuring these is the key. Is 3I ATLS water-rich like the comets from our own backyard, or is it made of a more exotic cocktail of ices, pointing to a very different, very alien birthplace? The answers are locked in that infrared light, promising a revelation that could rewrite our books on how star systems are born. The more we learn about 3I ATLS, the more it seems to break the rules. This isn't just another interstellar traveler, it's a cosmic bundle of contradictions. First, there's its ridiculous speed. 3I ATLS is blasting through our solar system at about 210,000 kilometers per hour or 130,000 miles per hour. That makes it the fastest comet ever recorded. A speed like that isn't just a number, it tells a story. An object only gets going that fast after falling past countless stars over billions of years, getting a gravitational kick from each one that adds to its momentum. This incredible velocity tells us that 3I ATLS is ancient, potentially even older than our entire solar system. Second, its origin is a complete mystery. Because it's moving so fast, tracing its path backward to find its home star is basically impossible. As astronomer David Jewett, who led the Hubble team, put it, it's like glimpsing a rifle bullet for a thousandth of a second. You can't project that back with any accuracy to figure out where it started on its path. It came from the galactic dark, and it will return to it, its home forever a secret. But the biggest puzzle is its behavior. Observations from as far back as May 2025 showed that 3I ATLS was already active, sprouting its coma when it was still incredibly far from the Sun. At that distance, the Sun isn't warm enough to vaporize water ice. This suggests its activity is driven by something much more volatile, like frozen carbon monoxide or carbon dioxide, which turn to gas at far colder temperatures. And yet, separate observations have already confirmed the presence of water ice and vapor. It appears to be a strange hybrid, a mix of the familiar and the exotic that doesn't fit neatly into any box we have. So what is this impossible visitor? While the final verdict is pending the full analysis from the James Webb Space Telescope, the leading theories all point to a violent, ancient past. One idea is that 3I ATLS is a planetary refugee, a building block of a planet that was violently kicked out of its home system as it was forming billions of years ago. It's a stray piece of a world that either came to be or failed to around a long-dead star. Another even more dramatic theory suggests it could be a fragment of an icy planet that was shredded to pieces when it passed too close to a white dwarf, the dense, collapsed corpse of a star like our own. Whatever its origin, 3I ATLS isn't just a comet, it's a messenger. It's a physical sample from another star system delivered right to our doorstep. By studying it, we are in effect studying the geology and chemistry of a world we can never visit. It allows us to do comparative planetology not just with our neighbors, but with worlds across the galaxy. The discoveries of Oumuamua, Borisov, and now 3I ATLS have shattered the idea that our solar system is an isolated island. It seems the space between stars is a vast ocean teeming with these wandering relics. As astronomer David Jewett said, we've crossed a threshold where our powerful new telescopes are finally able to see this population that was invisible before. The complete chemical breakdown from the James Webb Space Telescope is expected in the coming months, and it could hold the ultimate answers to the 3I ATLS mystery. That data will tell us just how alien this object truly is. To be the first to find out what Webb sees, make sure you subscribe and hit that notification bell. You won't want to miss the final word on our impossible visitor. 3I ATLS is more than a scientific curiosity. It's a profound reminder of the sheer scale and chaos of the cosmos. It's a piece of another world, likely born billions of years before Earth, that journeyed for eons across unimaginable distances only to briefly swing by and say hello. It shows us that the building blocks of planets aren't confined to their own star systems, but are swapped across the galaxy like cosmic seeds. For now, this messenger continues its silent, high-speed journey. After it loops around our sun, it will be flung back out into the interstellar void and never to return. But the data it leaves behind will be studied for decades, reshaping our understanding of how star systems and maybe even life come to be. It leaves us with a humbling and tantalizing question. What other impossible visitors are still out there, hiding in the dark, waiting to be discovered?